Welcome to the Explainer. Today, we're diving into the surprising, hidden mechanics of Python's true and false. If you think you already know exactly how Booleans work, well, you might be in for a little shock, because finding out how Python actually processes logic under the hood, it's gonna instantly upgrade your coding.
Let's kick things off with a totally mind-bending question to test your intuition. What actually happens if you try to do math with a Boolean? Like, what does true plus 5 equal in Python? If your instinct is that it throws a type error or maybe just crashes the whole program, hold on to that thought. The real answer is going to completely change how you view Python's fundamental data types.
To solve this mystery, here's our roadmap. First, Booleans in disguise. Second, Python's falsy values. Third, real-world logical operators. Fourth, short-circuit evaluation. And finally, Pythonic best practices. Let's get right into it.
Section 1. Booleans in disguise.
Okay, so here's the big secret. Booleans and some unique binary monoliths existing in their own separate universe within Python. No, they're literally just the integers 1 and 0 in disguise. In Python, the bool type is a direct subclass of the int type. So true literally equals 1 and false literally equals 0. We're not talking about a rough equivalent here. It is mathematically identical inside the interpreter. And this is the absolute proof. When we print the type of true, sure, it says class bool, but if you use the is subclass check, it shows that bool inherits directly from int. Because of this, saying true equals 1 is actually a true statement, and false equals 0 is also true, which means, going back to our opening question, true plus 5 absolutely equals 6. Crazy, right? The absolute best part is that this upcasting isn't some weird quirk or hack you need to avoid. It's a mathematically intended feature. Think about it practically. If you have a list of flags, true, false, true, true, false, you can elegantly count the true values just by passing that list into Python's native sum function. 3 true values perfectly sum up to the integer 3. It's brilliant, it's efficient, and honestly, it's just beautifully Pythonic.
Moving on to Section 2, Python's falsy values.
All right, so this brings us to the whole concept of falsy. Now, falsy isn't just the literal Boolean false. We use this term for values representing mathematical nothingness, empty collections, or just an explicit absence of data that Python automatically evaluates to false when you put it in a logical context, like an if statement. It's kind of like the mathematical vacuum of nothingness. It's actually fascinating how perfectly this maps out. For mathematical 0, you've got the integer 0, the float 0.0, and even the complex 0j. For empty collections, we're talking an empty string, an empty list, a dictionary with 0 key value pairs, an empty tuple, or an empty set. They all evaluate to false simply because there are no items inside. And finally, the null or false category, which includes none, the explicit absence of a value, and literally the word false itself. Literally everything else in Python, it inherently evaluates to true. Up next, Section 3, Real-World Logical Operators. Let's ground this logic with some everyday analogies. Think of the AND operator as a strict security checkpoint. To get through, you absolutely need both a valid ticket and an ID. If your ticket is fake, meaning that first condition is false, the security guard doesn't even bother checking your ID. They just turn you away. Now contrast that with the OR operator. OR is like paying at a cafe where you can use cash or card. If you hand the cashier cash, a valid true condition, they're not going to ask for your card. Just one valid option is entirely enough to satisfy the whole transaction. And then we have the NOT operator. It simply flips the script, completely inverting the Boolean value to its exact opposite. Not true evaluates to false, and not false evaluates to true. It's super simple, basically acting like a light switch for your logic circuits.
Okay, Section 4, short-circuit evaluation.
This is where the magic really happens. Short-circuit evaluation is Python's built-in behavior of stopping the evaluation of a logical expression the exact moment the final result is mathematically certain. I mean, why do more work than necessary, right? This is where Python's laziness actually becomes your biggest asset, stopping evaluation the millisecond it knows the final answer. Imagine the Python interpreter making this split-second decision when it reads an expression like user and user.name. Step 1, it evaluates user. Step 2, if user is none, which we just learned is falsy, the AND operator stops immediately. It already knows the whole expression can never be true. And because of this short-circuiting in Step 3, the potentially fatal attribute error of trying to access a name on a missing user, completely averted. Python essentially protected you by giving up early.
Seeing this chronological behavior used in actual code for safe attribute access is honestly a total game changer. Look at this block. Because user is initialized as none, evaluating user and user.name simply returns none. The program doesn't crash. Python's AND logic just stops dead in its tracks at the very first false it sees.
And check out this OR pattern for default values. The setup x or default works perfectly because Python simply hands back the very first truthy value it encounters, not just the literal word true or false. If your config variable is an empty string, which is falsy, Python ignores it, moves to the right side of the OR statement, and gracefully returns your fallback default. It's such a wildly powerful one-liner.
Finally, Section 5, Pythonic Best Practices. Let's put all this theory into practice. We really want to move away from clunky, beginner anti-patterns and start writing truly elegant professional code. So we need to train our eyes to spot these red anti-patterns and immediately map them to the green do this instead patterns. First rule, stop comparing Booleans with == true. Because we now know exactly how truthy and falsy values work under the hood, you can simply write if is valid. Trust Python's native truthiness to evaluate your if statements directly. And similarly, please don't check for none using !=. Always use is not none, so it's perfectly explicit. Embracing these direct patterns makes your code read beautifully, almost like plain English. To wrap up this explainer, I'm leaving you with a quick flashcard challenge. Based on that falsy void we explored earlier, what does config or default return if config is an empty string? Think back to our cafe analogy and short-circuit evaluation. The empty string is falsy, right? So Python just continues to the right operand and returns the string default. So how are you going to use this OR shortcut to clean up variables in your next script? I highly recommend trying it out today. Thanks so much for focusing in with me on this deep dive, and I will catch you in the next explainer.